Hey bot builders. So, AI agents, they're everywhere. You've probably seen the articles. 32% growth year over year, 50 billion in projected market share value by 2030. The list goes on. You see that you can build them in under an hour with no coding. You think, great. You rummage around for an AI agent building platform and wrestle with all sorts of dependencies, tools, frameworks, and whatnot, just to build something less functional than ChatGPT. I've been there. In this video, I'm going to show you how to build an AI agent. By the end of the video, you'll understand the moving parts that make up an agent, how to build one, and why I think the reason people often get stuck is that they underestimate just how simple it can be. I'll be demoing 3 different agents that I built in less than a day altogether, not each. Oh, and I built them using Botpress, the only AI agent building platform that pays my salary. Also, you can find the templates for free in the description. So, let's get into it. So first of all, what is an AI agent? Well, from Sarah's article, an AI agent is an autonomous system that processes information, makes decisions, and takes action to achieve a goal. What does that mean? So traditionally, if you want to achieve anything with a computer, you have to come up with the steps and then do them yourself. With an AI agent, you give it the desired outcome and it uses that request to come up with the intermediate steps and use information and tools to execute those steps. The purpose of an AI agent is to add another layer of abstraction to not only automate tasks, but also the decision-making involved in accomplishing those tasks. Agents versus workflows. Anthropic, the people who make Claude, put out this article distinguishing workflows and agents. According to them, workflows are when the steps are explicitly defined by the developer, and agents are when the program works autonomously to determine the tools and evoke them. So, if a program classifies the user's query, then evokes the correct tool depending on the classification, and finally selects a course of action and returns the outcome to the user, that would be a workflow. In the case of an agent, you give it access to tools and information, write some instructions, and it'll execute tasks based on what the user tells it. Workflows are deterministic. Agents perform autonomous multi-step reasoning. Now, I'm not going to be super pedantic about the distinction because I don't think it really matters and it gets kind of blurry. Just about all effective agents have some element of handcrafted workflows. You should aim to build agents, but be prepared to workflowify anything that needs a little extra push. What does that mean? You come up with a robust prompt and a simple workflow, and if you don't get your desired outcome, that's when you start defining explicit steps. For example, say you have an agent with access to 3 tools: a food delivery service, a weather API, and the ability to read and send emails. You expect it to invoke the right one depending on what you ask it. So imagine you say, "I'm hungry." And it goes, "Want me to send an email to a restaurant about setting up a reservation?" Or you ask, "What's the weather next week?" And it says, "Sorry, I couldn't find anything in your inbox about the weather next week." That's when you want to break up the flow. Maybe classify the intent and then invoke the appropriate tool. It's still acting agentically. That is, it's making autonomous decisions about how to use the tools, like what email to send, what date to check the weather for, but you are ultimately breaking up the workflow. The key to building powerful agents is knowing what decisions to leave to the agent and what to define in the flow. Okay, now components. I like to break AI agents down into 4 components: an LLM, or multiple, instructions, knowledge, and tools. So for the LLM, these are the models underlying the technology. They're trained to predict how to respond to queries, which is why you get some freakishly human-like responses from AI nowadays. But it goes deeper than that. In an autonomous flow, these models can come up with what questions to ask so they can figure out which actions to take and then answer those questions. For example,
agent thinking, understanding user intent. The user said, "I want to order a pizza." Determine available tools, web search, phone call. Plan next step, thought, search for a pizza delivery service nearby. Agent action, execute web search, query, pizza delivery service. Agent output, message, "Here are some pizza places near you. Want me to call one?"
There are loads of models that excel at different tasks, and platforms make it easy to cycle between those models. As of now, the default model in Botpress is GPT-4o. It's a great all-around model, but you can play around depending on your use case. Claude 3.7 Sonnet is very good for creative writing. There are also smaller models that are great for simple decision-making at a lower token cost. It all depends on your needs. Okay, now instructions. When you ask ChatGPT a question, that's a prompt. The background information an agent has before you ask the question, those are the instructions, or the system prompt. This covers the personality, output format, and the do's and don'ts of your agent. There's an art and a science to composing these. In fact, there are a whole bunch of prompt engineering classes. You could really go crazy here. You can't see the system prompt, technically, but every now and then a popular LLM system prompt gets leaked, or they release it willingly. And I honestly don't think there's a better way to learn than by checking those out. I've actually dedicated a section to prompting later on, so we won't get too far into it right now. But let's talk about tools. External tools, integrations and APIs let your bot interface with other programs. You can get ChatGPT to draft an email and then send it yourself, but you can get an agent to automate that whole process. There are most commonly used business or management tools, like email, calendars, CRMs, spreadsheets, agile boards. servers. There are integrations to connect to external communication channels, like WhatsApp, Telegram, Messenger. There's also general stuff like web search. These basically cover all the bases of what a person would do with a computer, so an LLM isn't trapped inside a prison of its own genius. A sign of a good bot building platform is when they offer a way for users to build their own tools and integrations, and an ecosystem of those user-built integrations. As an aside, this is where you're most likely to need some coding knowledge. Lots of platforms are advertised as no code. That might be true for simple one-and-done flows, but realistically, I think it'd be hard to build anything useful without knowledge of JSON format and API calls. Take it from someone who spent an entire day debugging silly errors. I'd love to be proven wrong, by the way. Let me know in the comments. External knowledge. Your agent has to have access to external information to be helpful. LLMs have a lot of information and are great at answering general knowledge questions. But anything that's specific to you or needs to be precise and highly reliable, that goes in the knowledge base. The difference between data-focused tools like web search and external knowledge, like the documents you upload, while your uploaded documents form a curated private knowledge base that your agent can reliably reference for consistent, context-specific answers. Web searches are more dynamic but more costly. That's great for real-time, low-volume data. What we're calling external knowledge is explicit information you add to your agent. External because it's not encoded in your LLM. Information in your knowledge base is indexed, which means that an AI model computes its meaning and stores it in a machine-readable format. Indexing takes a bit of time and computation, but it makes your AI agent more efficient and better at searching for relevant information, so it's well worth it. Something like company FAQs, that's not going to be changing all that often, and when it does, every few months or so, updating that isn't such a big deal. Dynamic information, on the other hand, is added to the message context, which means it gets buried somewhere in the prompt. For example,
Assistant. The user asked, "Are flights from Paris to Austin cheap right now?" Received information on price for flights between Paris and Austin. Price insights. Lowest price, $1,339. Price level, high. Typical price range, $570, $1,050.
and then synthesizes an answer based on this info. That's fine for reiterating the weather or flight delays or prices, but it can be a lot less effective when you're searching through a long, verbose database like product descriptions. The lesson here is put as much as possible in your knowledge base and save dynamic searches for real-time or small-scale information. Your knowledge base can be updated fairly regularly, so don't worry about weekly or even daily scheduled updates. But adding information does take up time and space and increase search times, so save it for information you're actually going to reference. Like with all things, it's a balance. The anatomy of a prompt. Let's talk about prompting. Again, an art and a science. This generally comes down to trial and error, but there are resources to help you learn. A prompt can be broken down into 7 parts. I know it's a lot, just bear with me. Identity. This is the personality and a basic summary. Scope. What general tasks to perform. Responsibility. How to behave. Response style. How it should respond to the user. Guardrails. What not to do. Ability. Precisely what tools and actions your agent has access to. Instructions. What to do with examples of scenarios. This isn't my own insight, by the way. This is from the Botpress agent boilerplate. Good artists copy, great artists steal. This is a lot, and I don't recommend trying to memorize all of it. Structuring a prompt is about reverse engineering the logic. My takeaways here are this. 1. Make your prompt hierarchical. Identity, scope, details. Notice how it follows a funnel shape. It goes from broad to narrower with some redundancies. The summary will keep the agent in track of its bottom line, and the various sections color in the details. 2. Keep your prompt structured. Using Markdown with separate sections will help the agent compartmentalize information. As in, answer the question, but don't make shit up, but ultimately be helpful. I invite you to come up with your own philosophical insights. Leave them in the comments. There's a language and style to prompting. It's helpful to remember that LLMs are trained to continue text, so matching the style of other LLM prompts is the best way to replicate their functionality. Again, looking through other system prompts of working agents and bots is such a great way to learn. Okay, now in terms of the actual contents of the prompt, it's important to be concise and articulate. Vague instructions with a "you catch my drift" energy are not going to cut it. Run your prompt by ChatGPT and see what it thinks. Let a robot tell you how to talk to robots. Types of workflows or workflow architectures. So in that same article by Anthropic, published about how workflows are not agents, they list a bunch of different types of workflows. And I thought this was helpful. So in the spirit of not worrying about the difference between workflows and agents, let's talk about workflows for agents. So there's the sequential architectures, prompt chaining and routing agents. This is when an agent determines the outcome of a subtask and then passes that outcome on to the following agent. So like asking a customer for their order number and then using that to look up an order in a database. A routing agent means an agent classifies an input and then determines which workflow to follow depending on that. Parallelization is about agents performing separate tasks, but it's specific to when they can be performed in parallel, meaning the outputs of subtasks don't depend on one another. This could be like searching a bunch of different different channels and databases so they can be aggregated for lead generation. Now, when an agent autonomously determines what the subtasks are and how to delegate them, that's called an orchestration workers flow. I think that this captures the way Botpress works, and recognizing that has helped me understand what I do and don't need to focus on when I build agents. The last kind is an evaluator optimizer. That's when one agent performs a task and another one decides whether it's satisfactory, or if the first agent should try again, rinse and repeat. This is sort of how Botpress handles errors, and I think that's super rad. It does this on its own. You don't have to worry about it. So what's the takeaway from all of this? Keep it simple, stupid. We're asking for precise results from a sophisticated but unpredictable technology. Start with as few explicit steps possible and only elaborate when necessary. Break up error-prone or sensitive tasks. If you're having trouble getting the results you want, extrapolate certain parts into separate flows. But do this as little as possible, because too much dispatching could end up disrupting the smoothness. For example, if you've got a personal shopper agent, you want to be able to research products, chat, and fill the user's carts with the same autonomous agent. But maybe move to a separate flow for checkout so that the user's carts, their personal details, and their shipping information are set in stone before any money changes hands. Workflow architectures are another reason why I think it's a little bit misleading to tell people that agents don't require any coding. These architectures are based on software engineering principles and rely on an understanding of how computers run. Even if it doesn't technically require any coding, you can absolutely build an agent without understanding any of this. But the minute you hit a dead end, how do you get yourself out? Alright, so now that we understand the theory, let's head over to the Botpress studio, where I'll show you some of the demos I built. The links to these, again, are going to be in the description, in case you want to follow along. So we have our first agent here. It is a calendar booking agent that I called Olaf, because I like that name. And I'll show you how it works. Let's just make that bigger. So let's try starting a little conversation with it. I told it to be a sarcastic appointment booking agent, and it's doing that. Create an event for this Saturday. Ooh, I have a typo. It'll be fine. Ping pong with George. 2 p.m. Okay, Saturday is June 7th. Confirming the event before I bother booking it. Yes, book it. All right, your thing is booked. Here's the link in case you forget. And let's have a look. Cool. Ping pong with George, Saturday, June 7th at 2 o'clock. Great, that worked. So let's have a look at the flow here. The first thing that happens is we find the date, and we make sure we put that in the right time zone in the proper format. This is going to be important later. I'll show you why. Oops. Okay, and now we have one single autonomous node. Like we talked about earlier with flows, there's a lot of different things going on. So I start the conversation and then I tell it when I want to book an appointment or if I want to book an appointment, and it gathers a certain amount of information. In the case of our conversation here, all I said was Saturday. And what it gathers here from this create event card is basically all the other information that we need to book the event. So summary, description, location, start time, end time, and you could even specify a color, that it infers by itself. So basically, we give it some information. What it has to do is confirm the event. It has to come up with all the information on its own that I don't make explicit, like what the exact date is, what the start time is, what the end time is, basically how long to do it. And then it's got to confirm all that with me before it books, and then it books, and then it sends me a link. Now, this happens in a lot of different steps, and if you wanted to be really explicit about it, you can kind of check to make sure each piece of information is there. In the case of my bot, I didn't actually tell it what precisely it needs to know. I said over here, avoid being too helpful, err on the side of being underinformative. And how I could tell that this bot took it is that it decided to kind of be brief about the details, and it sort of figured out the rest on its own. Ping pong with George, Saturday, 2 to 3. It decided that it was going to be an hour long. That was the bot's decision. What else do I have going on there? It's all the components that we spoke about earlier. I also gave it a personality where it was sarcastic, disinterested and rude, give the impression of a receptionist with their feet up on the table, chewing gum, texting, and not making eye contact with customers. I don't care what you tell me. I think that's so much fun. Here's the link in case you forget. It's actually kind of clever sometimes. Now, the far and away most difficult part about building this bot was getting the date right. Because every time I booked an appointment, it would set a date for like sometime in 2023. And there's a couple pieces that I think helped with this. And to be completely honest, I didn't really follow my own advice, and I kind of threw the date in a whole bunch of places. So for one, like I said, I'm starting off by actually setting the precise date in the right time zone in a conversation variable. We have videos explaining the different kinds of variables and how they work. I can link to those. In a couple parts of the bot, I threw in an explicit reference to the today variable. So here, because I put the double curly brace around it, this actually evaluates to the exact variable in the ISO format in JavaScript. The same thing happens here. I put that in guardrails because I think that that's a really good place to articulate, hey, these are the pitfalls you should avoid falling into. Now, I didn't phrase this as a pitfall, and that might be a problem. But be sure to calculate the date of the desired appointment relative to today's date. And I also said that here, make sure you take note of today's date. I put the word variable, and that might have been an issue. Now, you also have a second chance to prompt it based on the create event card. So here, determine the appointment date relative to today's date. You could put instructions and you put them in plain language instead of passing explicit information, which you always have the option of doing. And I can imagine there's events where you're going to want to actually be really explicit about, I don't know, the start time or the end time or something like that. And in that case, you could insert it manually. And in those cases, you're going to want to actually extrapolate that variable at some point in your flow. Now, that's an example of where you break out a piece of your flow into a separate task and where you'd start to evoke something like a prompt chaining or parallel flow, probably prompt chaining in this case. So here in the instructions, I made explicit what I wanted. So determine the appointment date relative to today's date. And then I put today's date. This again evaluates the actual date, not just the name of the variable. And infer the time from the current time zone, which is EDT. If I wasn't explicit about the time zone again, then it wouldn't work. Now, in all honesty, there's probably a little bit of redundancy in this bot. And I really made this tutorial with the purpose of letting you know that you can build these bots quickly and they can be perfectly functional and helpful. I argue that this bot having like a really fun, sarcastic personality and also being able to kind of talk in a really conversational, casual tone and it still does the thing I'm asking for, that's a huge win. So I'm super happy with it. Anyway, yeah, that's it for my appointment booking bot. All right, bot number 2. This is Winona, my wine bot. She's back, except I have modified her. What I used to do is help the user pick out a wine just with access to this wine table. It is a list of different wines, their designations, their prices, points, and stuff like tasting notes. Where's that? Description, tasting notes, stuff like that. And you have a conversation. You tell it what you want, what kind of foods to pair it with and whatnot. And then it'll come up with a wine for you or come up with suggestions of different wines. So let's have a look at how that works. Hey. Hello there. Welcome to Why Not? How can I assist you today? Okay. Looking for something crisp to celebrate summer. Okay, now it's coming up with different wines from the catalog. This says the price and how many points. It's out of 100. Okay, so yeah, first things first, that's what it does. Now I split this flow into 2 pieces. Now this is a great example of, again, prompt chaining. Because, well, let's say now I want to buy one of these wines. What do I want? I want Leon Bayer. Something without accent so I can spell it. Can I get a bottle of the Leon Bayer? Okay, so it added one of those to my order. Now, if you look over here on the left, I created this variable where it stores this information. So it gives the index of the wine, that's just the ID, the way it recognizes it from the table, and how many I want. I want 1 bottle of number 12. Okay, so when you're happy with your order, we move on to the next part of the flow. As you can see, this is in orange now it's in blue, where we deal with basically the nitty-gritty of getting the order to the customer, stuff like their name, email address, delivery address. The reason we do this is because I wanted to demonstrate what it looked like to separate different characteristics of the flow into different pieces. For the agent who's in charge of doing the wine sale, I really wanted to give the sense of it being conversational and familiar, not necessarily someone pressuring you into buying something. And it even gives you the option to be like, hey, if you're just like window shopping, you can do that. No pressure to buy anything. But the minute you're ready to make a purchase, I want that part of the operation to be as painless as possible and not necessarily super conversational because that part isn't particularly interesting. So here, let's say, now in this case, I give it stuff like my name. Ben is my name, Ben Wino at yahoo.com. And then my address is like 123 Grape Street. So it's saying your order for 1 bottle of Leon Bayer was placed and the total cost is $30. I made sure that the bot would actually tell you what the total order was at the end and it'll be delivered to my address. A confirmation email has been sent to my email address. Now I didn't actually hook up email to this, but I did tell it to tell you that. And now we have a look at the order table, which is where we store the information about orders. Cool. So moments ago, this is the order that was made, this is the wine, my name, and my information. So this is stored for record keeping purposes. So we have business in the front and party in the back, or I guess the other way around. So that's it, that's everything. Now, this is another great example of taking the flow in different steps in each one of these two nodes. Figuring out the wine you want and how many you want, and then storing it in the variable. That happens in different steps in different orders, depending on the way the user interacts with the bot. This could, again, in another world, be an explicit step-by-step flow, but instead I think it feels a lot more fluid and conversational because of the way that we're doing it. And same thing with the order information. I mean, I made this pretty speedy and painless. One thing that's really cool is that transitioning between these flows is also subject to a human-like conversational prompt. So the user has decided on a purchase. The node actually deciding on when that takes place is basically based on its interpretation of the prompt. So earlier we talked about the autonomous decision making, and I want to give you a sense here from the logs down below of what that looks like. So here's an example over here. When I asked for 1 bottle of the Leon Bayer, what happened is that the LLM had written this code. You can see code that here there's a comment up top confirming the availability of the Leon Bayer wine and adding it to the user's order, and then there's actual JavaScript code that does that. So workflow.wine order, it's actually finding the workflow variable over here and executing Java code to actually push a new item to that variable because it's an array. This is kind of what I'm talking about when I mention that it doesn't hurt to have some JavaScript and JSON knowledge. And then it comes up with the message. Another example is over here. When I asked for something crisp or refreshing, what we got is here, searching for wines that are crisp. Basically, the LLM wrote more code to find wines in the table that had words like crisp or refreshing. Now, at the moment when it decided to do the transition from the first node here to the sales flow, that happens over here. So this is the message it sent. I'm glad you're happy with your choice. I'll proceed with your order. If there's anything else you'd like, let me know. And then it calls the tool transition. All this was the LLM decided to do it by itself. It calls transition. It comes up with a reason. This is again summarized by the LLM. The user has decided on a purchase. Now, finally, property mutation, when it adds the information to the table. It took my message here where I specified my personal information, and it came up with the code that it needed to be able to write it. And Ben is my name, is what I wrote, and then I put that information verbatim, but it wasn't necessarily super clear. It was clear from a conversational perspective, but not from, a computation perspective, and the LLM figured that out by itself. So there you go. Those are all the decisions that were made behind the scenes. Anyway, that's it for my second build, Winona. God knows where this girl's going. She is a rock star. So this last example here I call RE Gross because it's a grocery bot. And this is an example of one where there's one simple node with, pretty thorough instructions, and it has access to a whole bunch of different actions. This is 2 different browser actions or cards and also a web search. We'll talk about the difference between those in a second. And then it also should be kind of reading from, updating, and writing to a table. What it does is it searches the web for different recipes, and simultaneously it also has a look at the grocery store's API for what's on sale. And the idea is it has a sort of creative conversation with me where it makes suggestions about how to modify recipes from the internet using products that are on sale at the moment. So let's have a look at it. Okay, so one thing that I wanted to show with this bot is that it'll start by doing actions before you actually ask it to. So right now it's looking at the API to find out what's on sale. So here it's showing what's on sale at this one grocery store near me this week. Now what's going on, because I started the flow, is that it's also looking for recipes. What I wanted to showcase here is the parallel flow. It's actually doing 2 different things. Now it's not explicitly doing them at once. That has to do with this bot building platform. It's not going to necessarily run them at the same time. Frankly, for what it's worth, it doesn't really matter. It grabs the 2 pieces of information and then it works with both of those. So I think we're fine either way. So now we have an example. I ask it to get 1 recipe. I'm trying to reduce the amount of noise when you look for recipes or look for ideas of what to eat and just tell you this is what you're eating. So here, I found a great recipe for dinner. How about chicken cashew and broccoli stir fry? And now it says, I noticed that cloverleaf tuna is on sale for 99 cents. If you'd like, we can substitute the chicken stir fry with tuna for a unique twist. This is not a food recipe gastronomy LLM. So, be forgiving. Although maybe it wouldn't hurt to switch it out for something like Claude Sonnet. We could actually give that a shot. That's cool. Okay, now I'll say something like, what veggies are on sale? Maybe I want to switch out the broccoli for something else. Here's some vegetables that you might consider as substitutes for broccoli. So we have mini sweet peppers or tomatoes on the vine. So of these options, what do you recommend? Snap peas and bell peppers. Sweet. They're on sale and you can replace it. Great. So we have our tuna possibly as a replacement for chicken, and we've got peas and bell peppers to replace the broccoli. So that's the LLM is thinking creatively, and it's also accessing the tools it has at hand. Good. Now let's see if it'll be able to run the grocery list. Can you add the tuna, peas, and peppers to my grocery list? Cool. Let's see if it worked. Cool, cloverleaf tuna, snap peas, bell peppers, gives quantities, awesome. So like I was saying before, let's try switching out the LLM, see how it does. What we're gonna do is go here to bot settings, and let's see what happens when we use, Claude Sonnet 3.7. All right. Everybody say a little prayer. Okay, we're back. Let's start it off. So now it's going to run a check at the grocery API and also find a recipe. This is a great example of something that could, I don't know, every day at like 3, you're feeling that little afternoon dip. It can message you, hey, I have this idea and that idea. Here's what's on sale, and here's what you can cook with that. Something to just give you inspiration so you don't have to go out of your way to figure it out by yourself. Okay, healthy chicken piccata. I hate people branding things as the healthy version of. Doesn't matter. This dish features lemon, capers, seared chicken. Check out the red. Cool. It gave me the link. Here's an idea. Since cloverleaf tuna's like, go fuck yourself. Any less gross suggestions? Maybe a different protein that's on sale? I noticed that fresh pork tenderloin's on sale and fresh pork loin chops are on sale. How about substituting the chicken in the healthy chicken piccata recipe with one of these? That is good. That's actually a really good option. That isn't asking you to put a can of mealy-ass tuna inside a chicken piccata, which for the life of me, I don't even know how you would do that. Amazing. So we switched up the model. 9%. This gives you an overview of what's on sale. It doesn't tell you everything. I like the idea of reducing the options and having the LLM sort of, I don't know, cleverly decide what information to show you, what to filter, and then come up with ideas based on that. I really like that. There's a difference between browse pages and web search here. In the case of web search, it really just does a search engine query. You know, something like Googling, but in this case, it might be the LLM or the LLM provider's own search engine. I'm not actually entirely sure. And that comes up with certain results. And the ability to browse pages gives you the option to look more closely at the contents of a certain website. Now, in the case of finding the recipe, it is not entirely necessary. It just kind of gives the picture and the title with a brief description, which is all usually available from the page's meta information or the search engine information. But in this case, you can kind of go deeper. You can go, can you summarize the chicken recipe real quick? Cool, yeah, and it gives it in point form, which is what I asked it for. I can just go to the website if I want a step-by-step, but instead, you know, lemon juice, capers, garlic, chicken is seared until golden, then simmered in a light lemon caper sauce. Yeah, you can figure that out yourself, or you could have a look. Amazing. So that's it. That's it for Ari Gross. So yeah, that's it. So you've got everything you need to start building AI agents, the platform, the theory, and an arsenal of prompts. Now, all you need is some practice. We've got you covered. You can start using Botpress for free. Also, like I said, my templates are down in the description for you to take. Great artists steal. If you're looking for inspiration, we've got articles on use cases. If you've got questions, we've got a bustling Discord community and a library of tutorials. So go crazy, build some stuff, have fun. These things are powerful and only getting stronger. And make sure you let me know in the comments what you want to see next. Till then, happy bot building.